what I want to talk about today is blockchain and, a little bit of its relationship to cryptocurrencies. The blockchain is not a fashion, it's not a fad, it's here to stay. We're gonna, have blockchain with us, for the indefinite future. We started in computers, as you can see from my white hair, I'm an old guy with computers. So I started with the servers when there was only one PDP-11 machine in a company, and we would take turns using it. Then it developed, they became a bit stronger, and, we were connecting to them via terminals. Terminals were thick, connected to the server with thick wires, and from there we went on to the PC era, and that was mid 80s till 2000. And from there we went to the internet era, and we're still living that era. The problem with the internet is that it's anonymous, in the sense of when you say you put a file on the cloud, you don't know where that file is. That file is just on, some computer somewhere. You may have a URL that takes you to the location of your file, but you really don't know where physically your file is. Blockchain is organizing the internet in a way. So it is the next phase of the internet, the next phase of computing. It provides both a decentralization, but an organized decentralization. So this is very important. The purpose of these talks is to, we want to internalize these technologies. We want to adopt them and not only use them, but to develop them, because I will explain more about the reasons for that. But we have to own these technologies. We can't just carry on like we did in the last 40 years or 100 years of just copying and using the technologies developed by the West. So, it's a new type of technology, and the basic point, of course, the term blockchain comes from the information is stored in the form of blocks, and these blocks are very clever. I'll explain in more detail. They are encrypted to start with. Then, if it's a big file, let's say it's a 1 gigabyte file, it will be broken up into chunks. These chunks will go into blocks, and each block will be encrypted, will be fingerprinted, and stored multiple times. This way, we've got a lot of things that are needed in servers and so on already implemented. So we have the encryption, we have the multiple copies saved, so we have backup, and it is sitting there in a peer-to-peer network. So it's, one very important feature here is that if for any reason one of the blocks is corrupted on one of the servers or one of the computers, the network has a way to check that. Now, one of the most important issues about the blockchain and so on is that it provides trust in the data. There is many levels of trust, but we started with tribal trust. You would trust your family, you would trust people you know. Then we went into institutional trust, and in the financial sector, that's banks. So the banks, when you want to transfer money, you go to a bank and you send it to someone else's bank. The bank is sure that you have the money that you're transferring. And this, gave the trust. We know that if we're supposed to be sure if someone writes a check that there is money, but of course the individual comes into play here. But, if the bank is the one who's giving you the money, you are sure the money is there. The next layer is distributed trust, and that came from, blockchain. This is just showing a bit more, so we have a centralized data architecture. That's the banks would be providing that. Blockchain is a distributed architecture, and and there is no one central point that controls all this. So to recap here, as an introduction, the blockchains are decentralized digital trust platforms. They were introduced actually in 1974 to enable the transmission of confidential files over a public network of computers. So the first patent that came on blockchain was really talking about, if I have a file and I want to send it to someone else, but I will have to go through servers that I don't own, the beginnings of the internet. You know, if I want to do that, how do I do that? How do I do that while maintaining the integrity and that the people in the middle can check the data without knowing the data? So what was developed then was the concept of a hashtag. And so basically you take your file, you encrypt it, and you know, now if you give it to someone else, he cannot check the data in it. So what they did was introduce the hashtag. The hashtag is basically a function. You take the file, you put it through a function, and the file, let's say in the case of Bitcoin or something like that, is 16 megabytes. You take those 16 megabytes, perform a function on them, and get a hashtag that's only 255 long. Now, anybody in mathematics understands if we have 16 million and it maps into 255, this is not a one-to-one relationship. A lot of those 16 million will map to the same 255. So what they did is they added a timestamp. Before the hashtag, you add a timestamp. So this is the file. This is the time I am sending it. I hashtag the two and send them with the hashtag. So the receiver, a file in a server in the middle, doesn't know the data because it's encrypted, but he can pass it through the hashtag function, produce the hashtag, which is like a fingerprint, and decide if the data is correct or wrong or not. He then gives it to the next computer and they do the same until it gets to the intended receiver. He can decrypt it and get the data. So this was a very nice concept, this concept of a hashtag. Now, the point is, can someone find another file, another block that maps to the same hashtag? Yes, but not fast enough. It will take him hours, if not, right now with a traditional computer, not a quantum computer, it takes 2 weeks to find a single file. So it's of no use, because that blocks are generated every 10 minutes. So you can't alter a block, within the period of generating blocks. But now the second question is, can you find a file or a block that maps to the same hashtag that is useful to you? That's practically impossible. So just corrupting the data is one thing, but corrupting it in a useful way, that of course is a different thing. So the way the blockchain files or blocks are generated is we have a genesis block, the very first block, but let's not talk about that now. So you have the very first block of data and you hash this block. Together, they form, and with whatever data you want to include, now you hash all of this, and that's one block. The next block has the hash of the previous block, hash of the block you have, and data, and so on. So it's a continuous chain of blocks, and that produces the name, or why it's called a blockchain. So it's a chain of blocks. Now, one more feature of the blockchain is what we or what the blockchain developers decided to do is you cannot delete or edit a block. The block is generated, it's forever there. And as you know, we all know that in computers, you have 4 functions that you can do with files. You can write a file, you can read the file, you can edit the file, or you can delete the file. Delete and edit are removed from blockchain. So blocks can neither be deleted nor modified. This is, of course, very, very useful for governments and for many organizations that want to have the records maintained. But so how do you make a change? Well, you go to introduce another block and explain in it what change you want to make. So contrary to common thinking, blockchain was not invented by Satoshi, whoever he is, or Craig Wright. The first patent referencing blockchain was in 1974. Satoshi publicized blockchain through the introduction of Bitcoin. He solved a number of issues that pertain to the public use of blockchain. But, was it the first even digital currency or cryptocurrency? No. In 1998, so about 10 years before Satoshi came up with the Bitcoin, there was something called BitGold that was introduced. But it had problems, and even Bitcoin has problems, and we'll talk about them later. But Bitcoin solved some of the basic problems that they had introduced a solution to double spending. And we'll get into these issues in a few minutes. Again, a hashtag is, or hashing is a very important part of the blockchain, and it is basically producing fingerprints of files. I want to, say this enough so that we remember it. Now, centralized trust through banks has worked well for decades, but the problems with it are it's single point of failure, and we all have experienced, sorry, the system is down, can be slow at times when a lot of people are trying to access the same server at the same time. It's slow, and you see it within online banking. Very often it's quite slow, and it's centralized control. Sorry, your account is seized. The governments can easily go in any time and freeze your accounts. Centralized control gave us comfort, of course, that the funds are 100% secure in the sense of, in transactions. We know that the transactions are very secure. If you transfer funds from a bank, you are sure the funds are in the system somewhere. Of course, mistakes happen, and if you enter the wrong SWIFT or something, it can disappear for weeks, but the funds are in the system. There is no way they vanish. Distributed trust introduces the problem of double spending. Now, the way the blockchain would normally work is, a change or a file would broadcast through the system. So it would be initiated by a few computers in the neighborhood of where the transaction happened. And then, other computers that were not involved in the transaction and were not involved in writing the block that includes the transaction, it will take time, and at the minimum of, I'll explain in a second, in the Bitcoin, it can take up to 70 minutes for the whole network to be updated with the block, so that the same block made it everywhere. Now, imagine if I want to cheat, and with my Bitcoin wallet, I duplicated it on another phone in another country. So say in Egypt, and I have a duplicate of it in Australia, and I have a third replica in the United States. If around the same time, within 5 minutes of each other, I spend the money on my I spend my coins in 3 different places, the network will not know. The network will accept the 3 transactions. What happens is you get branches now built on, and we'll call them branches, their main, the main trunk for the beginning, but we will get 3 trunks with those 3 different transactions or contradicting transactions. And things could build on those. So blocks will be made based on that wrong. One of them is right and the other 2 are wrong. Blocks will be made, a chain of blocks will be made on the wrong blocks. But once the internet or once the blockchain figures out what's going on, it will kill the 2 transactions that had the least blocks built on them. So the ones with the least consequences. So of course, it's a big problem if you're using Bitcoin to accept payment in a store. You can't hold the purchaser for 70 minutes to tell him, wait till I'm sure the funds made it. So, it's a problem not publicized because, of course, we don't want Bitcoin to collapse, or we don't want cryptocurrencies to collapse. A very important feature of the blockchain is smart contracts. And smart contracts are electronic contracts. They remove the need for escrow agents. For example, in the case of purchasing real estate, and you're paying, a few $100,000 for a real estate somewhere, there is always the worry of, if you paid and he didn't sign, or if he signed and you didn't pay. So what normally gets done in Canada and the US is we have escrow agents. So we have 2 lawyers. I will give all my papers to my lawyer. He will give all his papers to his lawyer, and they have an escrow agreement between the lawyers, and they make sure that everything happened in a proper sequence. Now, the banks, in a way, are our escrow agents, but and we do some things with the banks with letters of credit and bank guarantees. That is the same concept. In the case of blockchain, because we don't have financial institutions, we have introduced smart contracts. And it's basically the ability to say, I have to release this when something happens. And that thing is itself on the blockchain. So I cannot deny it. As soon as I scan something, it means I received it, finished. And I can't receive it. Say, it's with FedEx. FedEx would be tied to the process. As soon as I scan the code, it's finished. I received the shipment, he gets his money. Now, how actually does something like Bitcoin work? Okay, so in Bitcoin, you somehow ended up, some people, they're called the miners, ended up with coins. So what, do the miners do? The miners, or let's actually describe how Bitcoin was set up in the first place. So Bitcoin was set up by this, fictitious character, Satoshi, and Satoshi basically said that, he gave the rules of the blockchain, and anybody could download them. And when a transaction happened, so he issued the Genesis block and gave himself some coins, and started, and gave some others if he wanted to, in that Genesis block, the first block. In that block, some Bitcoins were issued. But from that day on, he said that if you want to generate Bitcoin, you have to help us verify transactions. So now today, 13 years into the event, if I have Bitcoins and I buy from someone else, so I raise my hand and say, I have 1 Bitcoin, and I bought something for 0.001 of a Bitcoin and I give a wallet. The wallet is the only thing, the wallet ID. So I give the wallet that I bought from. Now, of course, my wallet is the one saying that. So my wallet is saying, I have 1 Bitcoin and I am giving this wallet 0.001. The chain collects a number of these transactions, a lot of these transactions, okay, and makes a suggested block. What the suggested block will say, we know now the most recent block. So we have the block and its hashtag. We have those. We list data. The data is all the transactions that we collected in the last few minutes. While a block is made, there are transactions getting made on the side. We collect all those transactions for the next block. But our block is the transactions that happened in the 10 minutes we were generating this block, okay? So we now have a number of transactions, but who's gonna check that I do have 1 Bitcoin and that the receiving party, how much does he have? And now, how much will he have after this transaction? So the miners go and dig into all the blocks. Every 10 minutes, a block is generated for the last 13 years. You can imagine the amount of data, and it's a 16 megabyte block. So people have to sift through, and my transaction could have happened in 2009. So they have to sift through all the blocks till they find the most recent transaction I did. And they list that transaction, the block it's in, its hashtag, and then they verify me. They do the same for the receiver, and so on. Now, there would be millions of computers doing this in what's called mining pools. Pools are, each mining pool has maybe up to even 100,000 computers. It divides the work amongst them in a smart way so that you can quickly get to the, so it says to one computer, check these blocks, and another check these blocks. And the first one that finds the most recent, they accept that. There are many, many mining techniques. When you join a pool, you follow their technique, of course. And now, the very first transaction in the block is you award yourself as the successful miner. In the first round, it was 16 Bitcoins. Bitcoin's value is in $3. So you are awarding yourself $48 as a bonus because you solved or you made the block. Now, a lot of people can make these blocks. It's not hard, it's just tedious work. So with thousands of computers or hundreds of thousands of computers in a pool, they can solve this problem in less than a minute. So what Bitcoin did is they want to issue 21 million Bitcoins by March 2040. To do that, they needed the Bitcoins to be issued according to this 16, then it became 8. Every 4 years, I believe it divides into 2, so it became 8. And I think now it's sitting where it's a cusp between 4 and 2, so, and they want that the last Bitcoins, the 21 millions, gets issued in 2040. So they need it to be every 10 minutes. They calculated all this. So they introduce a complexity into the hashtag. You're not just producing a regular hashtag. They say, and the hashtag needs to have so many zeros in it. So you have to keep adding things to the block until you get the zeros. It is by trial and error. So you check all the data that's in the block, you checked it, you made all the transactions, you're sure, you probe the source of each of those transactions, the block that the most recent transaction by me is in. You have all that written, and I say you produce the block, you do the hashtag, doesn't work, you add few zeros, you do the hashtag until you solve the problem. You get the right number of zeros in the hashtag. That's one way. They complicate it in different ways. So it's called the complexity of the puzzle. People often talk about mining is solving a puzzle. That is the part where they're solving a puzzle. Now, what is the problem with that? A very big problem. We get over probably 20 million computers around the world working, and only 10,000 will win. So we are burning a lot of electricity in this process. They say that the blockchain, the Bitcoin blockchain right now burns more energy than Switzerland. And that's a very annoying and very worrisome thing. So the point about this is that this concept here is called proof of work. So you prove you solved the problem, you win. And it's a competition. So Ethereum, which came a few years after Bitcoin, decided to develop a different concept, which is proof of stake. So what they did is they assigned people to be the validators. So it's not that there is a competition, and if you own 1% of Ether or Ethereum, you are entitled to get 1% of the validations, and you get 1% of the fees that they charge. This is working much better on the energy, but anyone who uses Ethereum knows it's very bogged down these days. It needs a major upgrade, or it's going to collapse within the next 2 years. Sometimes doing a small transaction on Ethereum costs $200, and you're often just sending someone $20, but they tell you the network is so busy. If you want to do it now, this is what it's going to cost. If you leave it till it's not busy, it's going to be down to normal again. So, of course, the proof of stake, it's done based on your stake in the network. And the good thing about the proof of stake is, you have reason not to cheat. If you cheat, you destroy what you own. You own 1% of Ethereum, you don't want to destroy Ethereum. So this is the beauty of the proof of stake. Now, what we proposed, is to develop something that is more private and permissioned blockchain. Where I was coming from is about 4 years ago, really 6 years ago, in 2015, October 2015, I decided that the biggest problem in communications is many poor countries don't have communications. We're talking, in Africa here, we have countries 187 in the world, and up to 20 of them or 30 of them after that are in Africa, the lowest rate of penetration of communications. In Africa, we have 850 million people that have not seen mobile telephones nor internet. So this is a huge number of people. If someone could service them, he would make the biggest phone company in the world. Now, why they are not serviced is because the central office is expensive. The lowest price for a central office is a mobile switching office, and it's about $500,000 or $450,000 from a second-rate company. If you get it from a first-rate company, it could be millions. So the mobile switching office or the central office is the real problem in communications. if you have only 2,000 users within the area that's covered by a single mobile switching office or a switching office, a central office, you will never recover your money. So, and if we let America and Japan and these countries develop the next generation of telephony like they did with 5G and the proposed 6Gs, all they care about are higher speeds. We had recognized that the speeds that are available now in 4G are more than sufficient for human use. The speeds and the delay they are talking about for 5G is not for human consumption, or not for a mobile user. A mobile phone can only handle about 700 megabits per second, and that's lower than the highest speeds available in 4G and LTE. So, the speeds are sufficient for the poor countries to build very good networks. So we need to decentralize the central office, and that's when we decided blockchain is the right answer. So we decided that, Dr. Adil is present with me. Dr. Adil is my partner in this development, and we decided that blockchain is the right way to go to make networks of network, to make very small networks that are cheap, put a small blockchain computer together with an inexpensive switch. So the building block of a communications network comes down to $10,000, including the wireless. We can get communications all over the world. Now, so I decided I'm going to use blockchain. At that time, about 2018, came a paper from IBM that said that in all likelihood, all blockchains have a backdoor. This was a big shock. I don't know if you know, but Bitcoin is used for money laundering, is used for, some silly people would buy a present for a terrorist, an RBJ or something. It's incredible what people, allow themselves to do when they think it's anonymous. We can get into, who started it really and who's Craig Wright and all these things, but that's another subject. So when we decided to use blockchain, I looked at Bitcoin and Ethereum and realized they are developed by, Americans, and, in all likelihood, they have the back doors. So, I'll go to a blockchain that is not from America. So I chose something called DAT project, DAT project from Denmark. And I signed a deal with them where I'll give them 30% of anything the blockchain makes, like, the profits of the blockchain itself, against that they give me the source code. It's a public one, but they will cooperate, deeper kind of thing. And when I got the documentation, the first company they thanked was the Department of Defense in the United States. So I thought, forget this, I'm not going to use anybody's blockchain. We're going to write our own from scratch. When I hired my guys in early 2018, my instructions were, don't take a function you don't know the exact software that wrote it. So we wrote a blockchain from scratch. Ours is private and permissioned, and the private part is because in a telecommunications network, I can't have someone else be part of my network, but it's permissioned, meaning you can download our blockchain software, but you can't run unless we allow you to be part of the blockchain. Now, we need to state clearer. There are validators and there are storage computers that only stores the blocks. They can be not ours, but the validators will be checking those storage computers all the time to make sure that the blocks are correct. They'll check the hashtags, they'll check the block and compare them with each other. And if there is ever one that is wrong, or of course it can be more than one, we do a voting system. This voting system is very dangerous. This is in all blockchains. It's dangerous because If someone comes to a new blockchain that's not permissioned, he can easily put in more servers than the blockchain has and control the blockchain, literally hijacks the entire chain, and introduce his data that's totally wrong. The blocks could be very, very different now. We're not talking just about he changed little things in the blocks. No, he can give all the money to himself or all the crypto to himself. So it's the regular blockchain is is dangerous in that way, or has a big weakness that way. Of course, the biggest safety is in the number of computers that are working on it. So private and permissioned is what governments need. It also, we don't allow anonymous users because we're a communications business, so we don't allow anonymous users. Every user must be known. We provided a smart contract platform. We use proof of stake, and it's a bit more than proof of stake. At any one time, when you connect to our blockchain, you're connecting via one of our servers. That server can do all the work for you. He will authorize the transactions, he will conclude things, and then he will send the transaction to be put in blocks and so on. But as far as you care, the transaction will be authenticated as if it's a central system. So we've mixed central with decentralized. So we've made dynamic block sizes so that it doesn't have to wait to have sufficient number of transactions to make a block. No, the block size can be varying. So we developed this in Egypt using Golang as our language. As I said, it's private, perfect for governments and large organizations. Now, here is the shocker. A backdoor can be installed to allow supervision. This is true, as I said, for all blockchains. And the key way they do this is they make a super user when they first generate the Genesis block, and that super user is a partner in all transactions. So he can see any transaction. It's designed to be fully customizable. So of course, we wrote it, we know every line, so we can change it. Uses its own cryptography algorithm. Now, of course, quantum computers introduce or pose a big threat to regular blockchains. So what we have to do is introduce quantum safe hashing and quantum safe encryption algorithms. And that means the most safe one these days is one that will change every 15 minutes. So we will update the encryption algorithm, not more than 15 minutes. So we're capable to processing blocks in less than 30 seconds. That's for the block itself, but the transaction is instant. We can instantly approve a transaction. Again, we go back to, it's no single point of failure. Blockchain are scalable networks, so it's higher speed, higher precision customer tracking, than traditional networks, faster connection, reliable service tailored to marketing campaigns. Now, one thing I need to say about blockchain, of course, number one is there are two sort of points that I want to say. It is cheaper on the infrastructure. So if you are a company and you want to, or a government, and you want to build a data center is very expensive with air conditioning and, a lot of things that have to go into a data center, including, big IT personnel and all these things. A blockchain can replace all that by using the excess processing power and the excess storage on your existing infrastructure, on your existing computers. So you have very small servers in a central location, and they manage the storage and the storage and the processing on the various computers. The problem with this is that it requires more data transfer. So, that's the the failure or the weakness in blockchain is that it is a lot of data transfers, because we are all the time checking the blocks that they're correct. We're all the time sending and making blocks and spreading them over the network. But the good thing here is that this is not the international internet. This is just the local internet. So it's, not all bad kind of thing. So again, I'm summarizing what I just said. The consensus algorithm, this is number 4, is what I described. It's, that if 50% agree that these are the correct blocks, they are the correct blocks. This is, and the presentation will be available. This basically, summarizes everything we said about the blockchain and how it works and so on. So, as we said, the user requests a transaction, a block representing these transactions is created. All the nodes get involved in verifying and validating the transaction. Then a block is added to the chain, and we start over. This is basically all I wanted to say. I know it's a very big subject. We can talk for just a minute before I close on applications. Of course, there are endless applications, and the beauty of the blockchain, of course, the organization developing the blockchain, like let's say a phone company in our case, can know all the users, but the users dealing with each other can be anonymous. So this is a good step for people that can be anonymous. Now, this, for example, I'm not going into the religious aspects of this, but for example, organ donation. This would be perfect for it, in the sense of you don't want to know who you received something from. It can be tied to the blood analysis and so on. And you can have a very good system without giving people priorities over each other. Blockchain can manage this to perfection. Data storage. Now, we talked about that blockchain does not allow editing or deleting, but that's blocks. The data itself can be stored independent of the blocks. The blocks can carry information about where the data is stored, which computers have the data. So, but the data itself can be erased, because many people get concerned. They may have a file that they don't want to exist after 2 years for many reasons. Well, they have the right to delete the file, but there will be a record of that there was a file, and that's acceptable, I think, to everybody. I say the applications are endless. We are ourselves using it for 3 or 4 things, and we can discuss more if anybody has questions. I thank you. I know, for some people that didn't know blockchain at all, this is a lot to digest. The presentation will be available to you, and I'd be glad to discuss anything or talk about anything with you. And I have Dr. Adil with me, and he can answer as well. Thank you very much all.